उसका उसका कोई वो नहीं है, आई मीन मोनेटाइजेशन वगैरह का सीन नहीं है, इसलिए मैंने उसको बहुत ज्यादा, ये एक जस्ट रिकॉर्डिंग स्टोरेज है।
Nice.
यस, या, ओके, सो शुड वी स्टार्ट?
Yes, sir.
बिस्मिल्लाहिर्रहमानिर्रहीम। Okay, जी, last time we discussed about Half-Life, right? Is that 16 shared with you?
Yes, sir.
Yeah,
Including.
so just a quick review about the Half-Life and then we will go to the major discussion of Half-Life. Half-Life में मैंने आपको ये कहा था कि Half-Life is basically that time in which half of the parent nuclei are decayed or half of the parent nuclei are left over. So leftover means, you know, unstable nuclei में क्या होता है कि they used to convert from one form to another form, from one nuclei to another nuclei. So overall, the number of nuclei remains same, but one type of nuclei is converted into another. So let's say मैंने आप लोगों को एक ordinary method समझाया था और एक technical method समझाया था. Let's say if you have n odd original number of nuclei and half lifetime of that sample is, let's say, represented by t 1 by 2, that can be in days, minutes, hours, years, even in millions of years. तो हम लोग ये कर सकते हैं कि n is the remaining number of nuclei of that sample after some time, जब आप लोग उसकी रीडिंग ले रहे हो. और इसकी मैंने एक एग्जांपल दी थी छोटी सी लास्ट लेसन में कि if I have a tank which with a capacity of 1600 liter and I now that it will get half of its original number after 2 hours. So when this number is reaching to 50 liter, 1600 liter pani pada hua usme, and after some time it is reaching to 50 liter. So I can imagine that how much hours it has taken or how much time it has taken to reach this number. तो मुझे ये पता है कि हर 2 घंटे बाद ये क्या हो गया हुआ, after 2 hours it has been halved. So after 2 hours it would be 800 left. After 4 hours 400 left. After 2 hours, sorry, after 6 hours 200 is left. After 8 hours 100 is left, and after 10 hours 50 is left. So it means half life क्या हो रही है आपकी, that is the that is a constant factor, and total time is equal to total time is equals to half life time into number of half lives, isn't it? Can I consider this, or can I develop this equation from this relation, that how is the total time related with number of half lives? Total time of decay is equals to number of half lives into time of one half life. Is it clear to all? So just I will write over here that total time equals to, yani total time lapse, you can say, that is equals to number of number of half lives into time of one half life, time of one half life. So please remember this thing, that total time is equals to n into t1 by 2. So here I told you that the one half life is 12, sorry, 2 hours. How much time, how, what is half life of one, yani what is one half life time? 2 hours. तो अगर आपके पास the sample is reduced or sample is observed after 10 hours, so in 10 hours how many half lives would taken place? 5 half lives will be taken place. So this is that game by which you can calculate the time taken. But there is another thing which is very interesting for you, कि half life के बाद sample के साथ होता क्या है. I will just make the calculations here on a blank screen. Originally it was 1600 and there was no half life, right? No half life, yani half life zero कह सकते हो आप लोग, right? Then it reached to 800. 800 आपका कब मिला? 800 is basically after one half life, after one half life. So what is this 800? Isn't it that 800 half of this, half of 600, you know, that is equals to 1 by 2. Is it?
Yep. Sir, but I have a question.
Okay. Yes.
It's like, does it only reduce by half? Like, not more than half and not less than half? Like, reduced by a
No,
quarter or something?
exactly half. No, 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 exactly half. So then it would reach to 400, right? After another half life, yani after two half lives, how much it will be? That is equals to yani 400. So 400 is basically 1 by 4 of your 1600, and then after another half life it would reach to 200, and that 200 is after three half lives. So after three half lives, if it is reaching to this, so I can say that it is 1 by 8th of what? 1600. Am I right? So in this way, when it would be reaching to 100, that will be after four half lives. So four half lives means it is 1 by 16th. So when it is 1 by 16th of 1600, so this all data will lead you to develop an equation. For example, here if I say that it is 1 by 2 whole power 1, here I can write 1 by 2 whole power 2. Here I can write 1 by 2 power 3. So, are you agree that 1 by 4 is 1 upon 2 power 2, 1 by 8 is 1 divided by 2 power 3, and this will be 1 by, basically it will be your 1 divided by 2 power 4, which is equals to 1 by 16, isn't it? Yani it is basically 1 by 2, it is 1 by 4, it is 1 by 8, it is 1 by 16. Am I right? And here, because there was zero half life, how many half lives do you have? Zero half life. So can I say 1 upon 2 power 0, which is basically equals to anything power 0 is equals to 1. It will be 1. Do you know this thing? Do you agree?
Yes, sir.
Okay, इसका मतलब ये हुआ कि this is what number of half lives. Here this is n. N is equals to 0. Here n is equals to 1. N is equals to 2. N is equals to 3. N is equals to 4, and so on. So here this number is this one. This number is remaining number of nuclei, right? Are you getting my point?
Sir, could you repeat like, the last
Yani
point?
this, yes, this complete, yani this is what? This is basically remaining number of nuclei. Remaining nuclei. Okay. And what is the original number of nuclei? Or let me call it, this one is only, this is original number. But after that, this is remaining. This all is remaining. This all is remaining. So now I'm going to make you clear that after zero half-life, remaining number is original number divided by 1. After one half-life, remaining number is original number divided by 2 power 1. After two half-lives, original remaining number is original number divided by 2 power 2. After three half-lives, remaining number is n original number divided by 2 power 3, and so on. So whatever the number of half-lives, n half-lives, after n half-lives, remaining number of nuclei are equals to original number of nuclei divided by 2 power n. So this is really, really, really simple to understand, that if you now the number of half-lives and original number of nuclei, you can just relate them together. तो इसका मतलब ये हुआ कि n, sorry, remaining number of nuclei is equals to original number of nuclei divided by 2 power n. So will you remember this equation?
Yes, sir.
Okay,
Sir, do I
so
need to
I'm
know
just
the
going to Mhm.
do I need to know the
Your
derivation?
question. नो डेरिवेशन इज रिक्वायर्ड. डेरिवेशन तो मैं आप लोगों को इसलिए करवाता हूँ ताकि आप लोग इसको समझ लो कि व्हाई आई एम गोइंग टू डू दैट. और जस्ट रिकॉल दिस. ये ना भी रिकॉल करो ना, इट इज नॉट मैंडेटरी. देयर इज एन ऑर्डिनरी मेथड एज वेल, राइट? सो फॉर एग्जांपल फ्रॉम दिस इक्वेशन यू कैन कैलकुलेट number of half lives, remaining number of nuclei, or original number of nuclei, anything. But there is another method. For example, if you have 1600 originally, right,
Yep.
or generally not 1600, whatever that is, and not originally, it will be divided by 2 after one half life, and not divided by 4 after two half lives, and not divided by 8 after three half lives, and so on. Are you getting my point? So, just for example, if you say that there are 1600 nuclei originally, then divide them by 2 for after 2 hours. How much? After 2 hours, because half life time is how much? 2 hours. And if you have 1600 divided by 4 for the calculations after 4 hours, and if you want to calculate after 6 hours, just do nothing. 1600 divided by 8. That's it. Because this 6 hour is three times of your one half life. So it is after three half lives. Is this all clear?
Okay. Yes, I got it.
Everyone done? So this is all what I told you in the last lesson, but I believe that it was something to be discussed in detail. That's why I just resumed that. Okay, I have to tell you again. So half-life can be applied in all type of these variables. For example, in number of nuclei, in count rates, in mass, in activity. Everything give you the same result, and you can calculate everything by the same methods. No issue at all. For example, sometimes it is asked here, okay, calculate the mass, calculate activity, calculate count rates per second, etc., etc. Okay, now this was the graph what I had to discuss, that according to half-life curve, you will get a decay curve, exponentially decaying curve. For example, if this sample is having a half-life of 12 hours, then I have put the interval of 12, 24, 36, 48. This is time in hours. Or in other words, I can say this is after one half life, two half lives, three half lives, four half lives. So this all is basically in number of half lives as well. So 1600 is originally number of nuclei, number of yani activity, number of count rates, mass, etc., etc. So after one half life, it would be half of the original. So what is half of original? 800. So you will spot 1 point over here. After two half lives, it is divided by 4. 1600 divided by 4, as I told you. So it would be at 400 at this point. After three half lives, it would be divided by 8. So for 1600 divided by 8 is what? Sorry, 1600 divided by 8 is how much? 200. How much is that? 200. So it is over here. Then after four half lives, 1600 divided by 16, so it will be 100. So you just spot all these points and join them, and you will get a half-life graph.
Got
Okay.
it, sir. Is the curve like
Sometimes
the curve thingy always like this, or is there anomaly sometimes?
there are some anomalies, but I will talk about those anomalies. I think I have considered those in my notes. If not, then I will draw it. Don't worry. They are that these graphs are not all the time something like this. Sometimes the graphs are something like this because of the randomness of the radioactivity. You cannot have a smooth curve. You will have some fluctuations, and this fluctuation is yani this abnormal behavior is the evidence of randomness. Okay,
Okay.
remember one thing. Then I told you that there is one more graph you have to now. Okay, let's discuss that in detail because in the last lesson we did not have too much time. Here I will just give you a table, and from that table you have to tell me something. These are original number of nuclei, these are remaining number of nuclei, and these are the decayed nuclei here. Okay.
Okay.
Okay, so decayed means decayed means the
The ones which have been reduced.
which are gone, yeah, which have been reduced, or which are basically converted into something else. Okay, which are converted into something else. Okay,
Okay.
these are the converted one. Okay, for example, initially there were 1600. Here it is number of half lives as well. After zeroth half life, no half life has taken place, so remaining numbers are 1600. Decayed are zero, nothing has decayed. Okay, agreed.
Yes.
After one half life, original number was basically 16. It was definitely the number of sample, any value of sample. What would be left behind? 800 is left behind,
Yep.
and 800 is your decade. After two half lives, remaining number is 800. Oh, sorry, just a second. Original number is 1600, right? Now 400 are left behind, but till this time 1200 have been decayed. Are you getting my point?
Oh, you write
After
the
three half
total
lives,
decay.
huh?
You write the total decayed, right? Like in the
Hmm.
second half life, it was like
In the
totally
last
from
column,
first
I
half.
have written the decade which have been just uh, disintegrated or decayed. So you are left with 200, and decayed are how much?
To no wait, to 800, 1200, and then 14, 15. Yeah,
Yeah,
1400.
1400. Okay. Then out of 1600, they will be 100, and they will be 1500.
68.
Are you getting my point? Yes, that would remain 1600, but this would become 50, and this would become 1550,
So I have a question.
and so on. Yes.
How did like in the second half life, the third half life, there were like 1200 to 1400. So
Yeah.
how is from the third half life to fourth half life there's just 1500? I mean, shouldn't it be 16 like the total thing? Or like
Check, it is 1550. So when you add these two, your number must be 1600. Simple is that. Yes.
but sir,
Is
shouldn't
this
it
clear
just
to all?
go over just four half lives? What is the need of the fifth thingy?
Fifth half life, sixth half life. You can be asked for any number of half life.
Uh,
Yes, Ariba, Khadija, are you people also there?
Yes, sir.
Hmm. So, is this also clear to you or not?
It is.
yes, sir.
Okay. And
No,
Khadija,
it's
आपको भी
not.
clear है? हाँ जी, मरियम आप बोलें.
It's not. I have a confusion.
Okay. Okay, so
So
let's.
like if it's like from the first half life to the third half life, if it's like the decay
Mhm.
is going like the pattern is very uniform. But then why does it not go that uniform in the fourth and fifth half life?
Okay, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is your 0, 200, 300, sorry, 400, 600, 800, 1000, 1200, 1400, and 1600. Okay, this is, let's say, one half life, two half lives, three half lives, four half lives, five half lives. Okay, so when there is no half life, number is over here. After one half life, your, okay, at that time, what is decayed? Decay will be here, is it?
But like you mean
मेरा बेटा एक मिनट में समझाता हूँ, थोड़ा सा तुम समझने की कोशिश करो। देखो, when there is no half life, all of your elements are undecayed, na?
get it?
Undecayed. So what is decayed then? Nothing, na?
Hmm. Zero.
So that will be zero. After one half life, how many have decades? 800.
800.
Okay, and how many are undecayed then?
1600 minus 800.
800, surely. Then after two half lives, how many are decades? Sorry, what is left after 200, two half lives? 400.
Yep.
400 are left behind. Then
Yes.
what is, yani how many are decayed then?
If like 1200.
1200. Okay. After three half lives, what is left behind?
200.
200. And it means 200 had gone. So how many are left over?
Uh,
Sorry, how many are decades? 1400.
uh-huh. Get it?
They got it.
Yes.
Okay. After four half lives, what is
Half life.
left? 100. इसका half
Yeah.
कर दिया मैंने. And
Yes.
what will be decayed then? 1500, na?
1500.
Okay. After another half life, only 50 will be left over,
Yep.
and it means 1550 are gone. So if you draw the graph of remaining number of nuclei, this will give you this type of graph. And if you want to draw the graph of decades, this will give you this type of graph. Now you got it?
Yeah. So the question will specifically mention which graph is to plot, right?
Yes, if the question is the graph of products, then you have to draw this black curve. And if the graph is the graph of remaining number of nuclei, then you have to draw this blue curve. So blue curve is remaining number of nuclei, and black is products. The
The decay.
beauty of this graph is wherever the graph overlap, after that the graph has a symmetric variation above and below. ये देखो, देख रही हो? Whatever is the difference from this line above, the same is the difference below this. This is symmetry of this graph.
Oh, okay. Got it.
So this is that point where remaining are equal to products. Got it? Is this all clear to
Yeah.
everyone?
So could you scroll up to the? Yep. Just a second. Done.
Okay. अब आप देखो, there would be some other graphs in which the graphs are random, right? Random mean it can be 0, it can be, let's say, 2 hours, 4 hours, 6 hours, and so on. So for these type of graphs, you have one situation. These are the random graphs, and this graph is to give the calculations of half-life. So when they are used to give calculations of half-life, just do one thing. Just start from a number. Let's say that number is 1600, and find half of it, right? What is half of that 1600? 800. So it means 1600 to 800, it is half decay, right? Half of the elements are decayed. And just go from this 800 to the curve, and from curve go back to the x-axis. This is basically a pattern to find out the half-life. Yani, this is a start, this is end. In this way, whatever the number you hunt from x-axis, that is your half-life. Simple, right? For example, if I start from 800, 800 to 400, I will go this way, then 400 to the curve, and then from curve to x-axis. It means the half-life is 800 is over here, 800 was at this point, right? So this is the half-life.
Sure.
Okay.
Can you explain this again?
Yes, let's say we have a random graph. अभी हम लोग ग्राफ ड्रॉ कर लेते हैं और फिर उसमें से मैं एक्सप्लेन कर लेता हूँ. In this graph you have just nothing. You people have to find out the half-life. For example, the given values will be, suppose it is 1, 2, 3, 4, 5, 6, 7, 8, the same numbers. It is your 1600, okay, and then this is your 0, then it is 1400, again 1200, it is your 1000, it is your 800, it is 600, 400, 200. Okay, yes, it is fine. 0, 100. अब देखो प्रॉब्लम क्या है. Problem is, let's say I have given you the time randomly. Suppose the time is 0, um, 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's say 10. So I have given you time in minutes. Okay, 10 minutes. So there is a sample. I have a graph of decay, something like this, right? I just drew the graph now without any intention, without any calculation, without any specification. So I asked you, calculate half-life. What to do? Calculate half-life from the graph. So how will you calculate half-life from the graph? That is, you will select any point by your own choice. For example, if I select 1600, I will figure out that, okay, if 1600 is original number, its half is equals to how much? 800. Okay, I will go to curve. Okay, 800 is at this point, I mean to say this point. Then
Then
I will check
I will check
from here to here,
from here
and
to
then
here,
I will
and then
find
I
out.
will find out
This is
this is
2.5 minutes
2.5.
if if you note down. Is it?
Yes,
Are
sir.
you getting my point?
Hmm.
दोबारा बताता हूँ, टेंशन लेने की जरूरत नहीं है.
तो लाइक जो
देखो,
मतलब ग्राफ बनाया उसका बस हाफ करके प्लॉट करके हो जाता है, तो लाइक इज इट समथिंग?
दोबारा दोबारा बताता हूँ. आपने यहाँ से शुरू किया, ओके, एंड यू गो टू हाफ ऑफ द नंबर यू हैव सिलेक्टेड. और वो क्या है? 800 है,
जी
ठीक है ना? आप 800 पे पहुंच गए, फिर आपने देखा कि 800 पे कर्व पे क्या पोजीशन है, देन यू वेंट टू द कर्व फ्रॉम देयर, ये पहुंच गए, ठीक है? एंड देन फ्रॉम कर्व यू हंट द टाइम, यार टाइम कितना है उस पे। तो बेसिकली आई टोल्ड यू दिस इज योर स्टार्ट, राइट? 4, फिगर ऑफ 4 याद रखना आप लोगों ने, एंड दिस इज द टाइम एंड दिस इज बेसिकली 2.5 minutes. So the first half life has taken in 2.5 minutes. Is it? Am I right?
जी
Okay. अब आप अगर चाहते हो कि नहीं मैं कुछ और इसको मोर एक्यूरेट लेके जाना चाह रहा हूँ, एंड आई विल सजेस्ट दैट यू मस्ट हैव सम मोर एक्यूरेसी, फॉर दैट पर्पज व्हाट विल यू डू, यू विल गो फ्रॉम 800 टू 400। आप देखो नेक्स्ट हाफ लाइफ कब हो रही है, यानी नेक्स्ट हाफ कब हो रहा है आपके पास, नेक्स्ट हाफ 400 है ना, है ना?
जी सर
800 का हाफ 400 है ना?
जी
यस, आपने अगेन फिगर ऑफ 4 को फॉलो किया एंड यू स्टार्टेड राइट फ्रॉम 800, व्हेन यू रीच टू 400 यू जस्ट मूव्ड टुवर्ड्स कर्व, और कर्व के ऊपर जब आपने टच किया तो यू मूव टुवर्ड्स एक्स एक्सिस, एंड यू फाउंड कि इस पॉइंट पे यू हैव 5.5 minutes. Got it? Is this point clear to you?
यस
Yes, sir.
इसका मतलब ये हुआ कि this time is time of second half life, so it is 5.5 minus 2.5, तो ये 3 minutes का half life time हो गया. This is the first half life time, so this is what, this is your 2.5, है ना? So I will calculate that first half life is equals to 2.5 minutes. The second half life is equals to 3.0 minutes. It's your choice if you want to calculate third, but no issue at all. So you can calculate half life is equals to 2.5 plus 3.0 divided by 2, because you have calculated two times, you have measured two times. So what will be the answer? 2.75. ऐसे ही होगा.
जी सर ऐसे ही होगा
So this is
Yes, sir.
basically the average half life, or you can simply say that I have taken average, just to make my answer more accurate. तो इस method से आप क्या करोगे? You will use this graph to find the half life. Anything unclear till this point?
नो सर नाउ इट्स क्लियर
Very good. अब आपके पास आ जाता है the game of background radiations. Okay, so this all was there. So I have I made you clear. So मेरा हाल है इसमें कोई प्रॉब्लम नहीं होगा आप लोगों को अब, ठीक है? अब आप देखो, there is a situation of half background radiation. So first of all, we should know that what are background radiations and what is their impact on the activity, and what is the what is their impacts on measurements. Okay, तो जैसे अभी मैं आप लोगों को पढ़ा रहा हूँ, this is what यानी you are hearing a background noise, and this background noise is sometimes increased, sometimes it is decreased, but it is there, isn't it? ऐसे ही होता है ना? So in the same way, when you are taking some readings, there are some radiations available in the environment even without source. For example, अब मैं अगर नहीं भी बोल रहा हूँ ना, so do you hear some background noise? ये देखो, कोई नहीं था बाहर, कोई था, वो दोबारा नॉक बेल करेगा फिर खोलेंगे जाओ. Okay, is it clear to you? So background radiations are same like your background noise. So I am the source of radiation, but along with my voice or my loudness or my signal strength, you are hearing some additional ones. So वो additional ones तो आपके पास होंगी. For example, if I'm in an environment जहाँ पे आपके पास constant background noise आएगा, let's say जिस तरह हम लोग fan चलाते हैं during summer, तो आपको एक constant background noise आ रहा होता है. So that background noise is just eliminated from my signal strength. Let's say मैं अगर ये कहता हूँ कि my total signal reaching to you is 50 decibel or whatever that is the loudness, then the background noise is, let's say, 2 decibel. So you will just eliminate that. आप क्या करोगे? Do you accept that background noise or not? But until unless it is unavoidable, बहुत ज्यादा हो जाएगा, तो तब आप लोग उसको रिमूव करने के लिए मुझे कुछ बोलोगे कि सर बैकग्राउंड नॉइज बहुत ज्यादा हो गया. But until unless it is in the tolerance or in your bearable situation, you will just take no remedy against it. इसी तरह you have very common sources which are unavoidable basically. उनमें से एक आपके पास radon gas है. You cannot avoid the radon gas because you people are here in your and in your atmosphere radon gas is there, and almost 50% of the background radiations are there which are contributed from radon gas. Then we have some rocks and buildings in our surrounding. In rocks and buildings में बहुत सारे elements हैं. Basically आपको पता है there are so many elements which are included in the rocks or formation of the rock. So these elements are radioactive. They just provide some sort of radiations. Then you have some medical installations, just like the X-ray machine कहीं लगा हुआ है, CT scan हो रहा है, you are having some sort of nuclear factory nearby, etc., etc. Then we have some food. You people will not believe it. Food is also causing some sort of background radiations. ठीक है? Then there are some cosmic rays and then some others. So these all are those radiations which are available, but background radiations are not harmful because they are very low in number and their count rates are 20 to 100 count rates. ये जिसका क्वेश्चन था just a minute. So 20 to 100 count rates means, जैसे मैं आपको नॉइज का एग्जांपल दे रहा था कि sometimes no one speaks behind me, तो आपको ऐसे ही लग रहा होता गली में कोई बाइक गुजर रहा है या something like that, तो that is very low background noise. But when someone speaks nearby me, तो आपको background noise बढ़ जाता है. And that noise is not that much कि मेरी आवाज से ज्यादा नहीं हो सकता. So I am the source of noise. I mean, हाँ noise ही कह सकते हैं, but not the background noise. So background noise have very low values. That is why it is not harmful. In the same way, background radiations are not harmful for the people living over here. ठीक है जी? अब आप बोलिए, what is your question?
Sir, but then it's accurate if you like with the background
Sorry?
radiation.
Can you repeat?
I'm saying, but then like if you measure the amount of radiation, how would you
Mhm.
exclude the background radiation? Because like wouldn't your reading be affected by the background radiation, even though if it's a little bit, but like it affects the accuracy, right?
Yes. So exactly. After that, we have a slide of background radiations correction. ठीक है? बस ये तुमने सोचा और देखा, तुम्हें मिल गया. ठीक है? So we are going to have some correction in the background, यानी correction due to background radiations. अब आप देखो, for example, if a sample, you are going to test a sample, the same sample, ये जो 1600 वाला चल रहा था, I told you that before that I did not have any background radiation source, but now I have a background radiation source which have 28 background radiations, and without source I just tested the sample, yani sorry, without sample I just tested the environment, atmosphere. मैंने यहाँ पे क्या किया, I just put the detecting machine, ठीक है, और I noticed कि यार there are some sort of counts on that. Basically, that is your background counter. Okay, I just put that counter here. This is your GM tube. ठीक है, तो आपने यहाँ पे सोर्स के लिए सोर्स नहीं रखा हुआ. देयर इज नो सोर्स. इफ देयर इज नो सोर्स, तो यहाँ पे काउंट रेट वैसे क्या होने चाहिए?
If there is no source of background radiation,
There should not be any signal, is it? There should not be any value. But still, I told you that without any source, if there is 28 number appearing on the screen, it means that there is something which is not visible to me, but uh, we have it. Is it ना? अब आपने क्या किया? You placed some source there, right? Again, counter rate sample आपका वही है, same thing, ठीक है? Them, and now you have source. Source means a lead block container के अंदर आपने क्या रखा हुआ है? You have a radiation source, and when you place source along with that, basically source is radioactive. Everyone knows source is radioactive, so immediately the reading is just enhanced, and let's say it reached to 1628. So what does it mean?
but it has increased. There's like from the source and the background radiation.
Yes, this is basically 1620 is not only source value. That 1620 is the reading due to source and sample both. Sorry, source and background radiations both. Now, when I corrected, what I did, the reading due to sample only. This is what, this is the reading due to sample only. That is 1628 minus 28. So you got again 1600. This is correction. Simple. So correction आपने ऐसे करनी है, आप कोई सोर्स नहीं रखें और काउंट रेट नोट कर लीजिए. This one. Then place the source and note down the count rates. Then subtract them. Simply. It is the correction. Is it clear to all? Okay. Now, how to apply half-life? सबसे बड़ा problem यहाँ पे आता है कि when you are going to apply half-life on such a situation कि where you are having some background radiations. देखो, let's say, पहली बात तो मुझे आप ये बताइए कि is it possible कि background radiations will have a half-life?
I don't think so. I mean, they're so minimum.
Yes, anyone else, any nuclear scientist in my class? The sleeping nuclear scientists? Hello?
Yes, sir.
Yeah.
Yes, sir.
Is it, do you believe or do you think that there will be a half-life? Yes, Khadija kidhar hai? Khadija, yes.
Yes, sir.
खदीजा, मुझे ये बताओ कि is it possible कि आपकी जो background radiations हैं, they will also get half and half and half?
Like background was like अपना क्वेश्चन
Background
रिपीट.
radiation. मेरा क्वेश्चन ये है कि background radiations कभी half हो सकती हैं, उनके ऊपर half life हो सकती है? Yes, Ariba?
Yes, sir.
Ariba?
जी.
Ariba, आपको आवाज आ रही है?
Sir, can you hear me?
Yes, I can.
Okay, Alhamdulillah. I didn't know because you
Good.
kept saying it very when I was speaking.
Now my question is there a half-life in background radiations?
Half-life in the background. Probably. I mean, no, there isn't. They're too small. There's nothing to
Hey,
decay.
good. Oh, very good. And yes, Zainab, आपका क्या ख्याल है?
सर पता नहीं, मुझे लग रहा है कि है. I don't know why.
Oh,
But they
I
all said
see.
no.
Great.
They all said
They
no,
all said no,
so I'm gonna
but
go
they
with
did not give me any logic. Basically, background radiation is a constant number you ever get all the times. आप अपने घर में जब भी source on करो, detector on करोगे, so you will have almost this number. Almost. ये जरूरी नहीं है हर time 28 ही मिले, but you can have these radiations plus and minus 28 मिलेंगी आपको. So there is no half-life on the background radiation. Remember this thing. This is a compulsory, note. You must know this. Everyone must know that no half-life takes place in background radiations. They are always constant, almost constant. So ये जो रेड में मैंने स्टार करके लिखा हुआ ना, ये सबके सामने लिखा हुआ था मैंने. I did not hide it. लेकिन ये जो मेरे न्यूक्लियर साइंटिस्ट है ना, छोटे छोटे न्यूक्लियर साइंटिस्ट, ये तुम लोग देखोगे नहीं तो कैसे करोगे काम भाई? तो नो हाफ लाइफ टेक्स प्लेस ऑन द बैकग्राउंड रेडिएशंस. लाजमी याद रखना है, लाजमी. दिस इज द पार्ट ऑफ योर ईमान इन न्यूक्लियर फिजिक्स कि नो हाफ लाइफ टेक्स प्लेस इन बैकग्राउंड रेडिएशन. दे विल ऑलवेज बी देयर. नाउ देन व्हाट हैपेंस, यानी व्हाट टू डू? You have to apply the half-life on the sample, which is to be halved. आपने half life सिर्फ किस पे अप्लाई करनी है? सैंपल की रीडिंग पे. सिंपल एंड स्ट्रेट. बिकॉज आई told you that your sample reading will be decayed. Sample will halve. तो अब आप देखो, I am just going to show you this corner of my slide कि आपके पास एक जगह पे टोटल रीडिंग कितनी थी? 1628. And what was the number of background radiations? 28. It means what was the sample reading? Yani what was the reading due to sample? 1600. Do you people believe it?
yes.
Okay. After one half life, after first half life, what would be the sample? आपने ये central column पे focus रखना है. इधर तवज्जो मुझे इधर चाहिए, इधर. ठीक है? After first half life, what is your sample? How much sample? Yani what is your sample reading? 800. And what would be the background radiation available at that time also? 28. So what would be your total reading available?
800 plus 28.
Yes, 828. Okay, after another half life, 800 has been reduced to 400. Is it?
Yeah. Yeah.
And during that, background radiation stays constant. It means your total reading is equal to what?
428.
Okay. After another half life, 400 has been reduced to 200 and 28 is still there. So what is your total count rates? 1280, 280, 228. And then finally, when half life has been reached, ये आपके पास हो गया third half life, fourth half life, fifth half life. So when the sample reduced to 100, your total number would be 128. Got it?
So what if it reduces more?
Wait. Now it reduced to 50. कि तुम अपना माइक थोड़ी देर के लिए ऑफ रखना बच्चे. अगर बोल नहीं रही हो तो जब बोलो तो ऑन कर लिया करो और जब सुनो तो ऑफ रखो इसे.
Yes, sir.
Okay, so it is 50. So the background radiations are now sample is going to give you 50 plus 28 is still there. So what will you get? 78. After another half life, this would reduce to 25. It is still 28. What will you get now? 53. Okay, and so on. When this sample will reduce to 12.5, this will be 28, and your value will be 40.5. When it would be 6.5, then it will be 28, your value will be 34.5, then it will be 3.5, and so on. अब देखो ये जब 3.5 हुआ तो now you are in the range of 31.5, then it will be 1.5, 28 will still there, so you will get 29.5, then you will get almost 28, and so on. So here your graph would become constant. Are you getting my point? Your graph will never go beyond this value of 28 or 30.
Got it, sir.
Is
Got it?
is this long discussion clear to everyone?
Yes,
Yes,
sir.
sir.
Okay, good. अब आपके पास दो कर्व्स बनी हुई हैं and you have to see these both curves. In curve, red curve or this pink curve, I have demonstrated कि 1600 is original number of nuclei. They reach to 800, then they reach to 400, then they reach to 200, and so on. But in the presence of background radiation, the graph is starting a little bit above. कितना है? 28 above. When it is 800, it would be 828, a little bit above. When it is 400, it is at 428, a little above. So all the times your graph will be a little above than the graph you have drawn without background radiations. Is this all clear?
Yes, sir.
This was the horrible topic. That's why I have selected that topic for you to teach in today's class. अब आप देखो यही चीज जो मैं अभी आप लोगों के साथ बोल रहा हूँ कि इन केस ऑफ हाफ लाइफ देखो नो रिडक्शन बियॉन्ड 28 बोला है मैंने ना वहां पे. So when there is no reduction beyond 28, your graph will become straight now. So whenever sometimes your background radiations are not given. This is very tricky question. When background radiations are not given, okay, it is not told you that okay, what is the number of background radiations, then what you have to do, you have to monitor the constant level of the graph and this point. So whatever this count rate is, this is the number of your background radiations. Okay. This is the number of background radiations. Got it?
Yes, sir.
Okay. अब रह गए हमारे पास तीन चीजें. One is use, second one is safety precautions, third one is hazards and radiation detector. So this all is the theoretical job. Uses would be quite easy. You will be able to handle them. Safety precautions उससे भी आसान है, and hazards, and then radiation detectors. I will send you the notes right now. You have to study those notes. If there will be something questionable, I will address that. Otherwise, this is your self study. Are you getting my points?
Ji, sir.
Sir.
जस्ट थ्योरी है, और अगर वो समझ पढ़ के आप लोगों को समझ आ जाता है तो देन इट विल बी फाइन एंड वी विल सेव द टाइम. और अगर आपको नहीं समझ आता तो यू पीपल विल आस्क मी एंड आई विल एड्रेस सम ऑफ द पॉइंट्स. मैं कुछ और नोट